Now here we go over the next set of formulae called as factorization formulae. To start off with, consider the identities that we saw earlier, that is the expansion of sine of a plus b and sine of a minus b. So we know that sine of a plus b is given as sine a cos b plus cos a sine b. Let's call this equation as equation number 1, and sine of a minus b is sine a cos b minus cos a sine b. Let's call this as equation number 2. Now if we add these two equations, then let's see what happens. See, on left side we will get sine of a plus b plus sine of a minus b equal to, on right side if you observe, the two terms of cos a sine b will get cancelled, and hence ultimately we will be left with 2 times sine a cos b. Alright. Now if for the time being we replace a plus b with a single variable, that is c, so what we get is sine c plus sine of. Similarly, if we replace a minus b with say angle d, that in that case what we get on right side is, if a plus b is equal to c and if a minus b is equal to d, then clearly on solving those two equations we get a to be equal to c plus d whole upon 2, and we get b to be equal to c minus d whole upon 2. So this is what we call as the factorization formula, because if you observe on left side we have a sum of two sine quantities and that gets converted into a product on right side. So therefore it is as if the two terms on the right are the factors. So therefore we call this result as the factorization formula. Now instead of adding the two equations, if we had subtracted two equations, we would have got sine c minus sine d on the similar lines to be equal to, the only change here now is that instead of sine cos order we get the order of cos and sine, the angles remaining the same. That means we have 2 cos c plus d upon 2 and sine c minus d upon 2. So this is the second factorization formula. And on the similar lines we can also proceed to find the factorization formula for cos of c plus d, cos of d, and cos of c minus cos of d. So just to recap these 4 formulae, on the next slide we have all of those written together. So here we can see that sine plus sine, sine minus sine, cos plus cos, and cos minus cos. If you observe, the 4th formula is a bit different, because on the right side if you observe, the last angle is b minus a by 2, whereas in all the 3 formulae previously the second angle is a minus b upon 2, whereas all the first angles are consistently a plus b by 2. So this we have to keep in mind, that the 4th formula, that is where we have cos minus cos combination, that is bit non-standard, or in other words whenever you have the product of two sines, okay, that formula is bit different from the remaining 3. Now the factorization formulae, as we saw, is nothing but they convert the sum to product, right? If we consider the opposite process, that is if we are given the product, then we can similarly convert them back into the sum. That is nothing but the defactorization formulae, and which we have already seen in the process. So let us once again go over those 4 defactorization formulae. Now here we are given the product of sine and cos. Of course we need a factor of 2 in the beginning to defactorize it. So that is equal to, on the right side, sine of a plus b plus sine of a minus b. So here also we see that the 3 formulae are similar, but the 4th formula is slightly not similar as compared to the rest of the 3. So in the 4th formula, first angle is a minus b and the second angle is a plus b, whereas in all the 3 remaining formulae, first angle was a plus b and the second angle was a minus b. This has to be carefully remembered and applied as and when needed.